In chapter 7, the second part is about a special function called the exponential function. In book 4a, you learn about what's the meaning of function. A function have two variables. In this case, we write y is equal to 2 to the power x. If you recognize the previous section, we just discussed the x is just an integer or an rational number. Now here, x is not just an integer and rational number. It can be all real number. If we write down this one, then we say it is called a function. Y is the function of x. But this one you haven't learned before because the variable x is in the index. If you putting a certain value, just like x equal to 1, then you put here, you will get 2 to the power 1 and get the y is equal to 2. And on the left hand side, it is called the domain, and you will find that we can put x equal to 1, 2, 3, and 4. But here you see one value will give one value of x, will give one value for y, so it is a function. And we say it is called an exponential function. But there's a special things here. It is a constant 2 here. So we will specify this exponential function with base 2. That means if I change this number become y equal to 3 to the power x, it is also called an exponential function. But it will be with base 3. Let's look at the example. But here you have a condition that this function, the a is just a constant like the 2. And this number must be greater than 0 and cannot equal to 1. We will explain why. Then when we write down y equal to a to the power x, it is called an exponential function with base a. You must know that this number is very important when you discuss about the exponential function, so the base must be clear. Let's look here, y equal to 3 to the power x, so it is an exponential function with base 3. Here y equal to 2 over 5 and then to the power x, it is an exponential with base 2 over 5. Here y equal to 1.6 to the power x, that is also exponential but with base 1.6. The following are not exponential function. Why? The first one, you see that y equal to square root x is just x to the power 1 over 2. And that means that the power is not a variable, so it is wrong. Similarly, for this one, the x is not in the base, in the index, so it is not an exponential. Although here you find that y is equal to a constant to the power x, but this is not exponential function. Why? Because in the definition, we must sure that the base must be a positive number. So negative 4 is not a positive, so it is not an exponential function. And why it is not equal to 1? If I putting the 1 here, I will get it is equal to y equal to 1 to the power x. 1 to the power anything is just equal to 1. So it is just a constant function. That means no matter what value you put here for the x, it still get the y value is 1. So this is not an exponential function. An exponential will have a different value of x, you give different values of y. And also if a is greater than 0, then a to the power x may not be a real number. Why? Because when x is just like the 1 over 2, that means the a to the power 1 over 2. If a is less than number, that means we take a square root of a negative number, so which is impossible. This is not a real number, so it is not an exponential. And also the x value can be any not real number, so we say it is the domain is all real number of x. Okay. If you have the function, then we can plot the graph. Basically, we use the previous example. Y is an exponential function of base 2. So y is equal to 2 to the power x. We can substitute certain values of the x and then find out the corresponding values of y by using calculator. Just fill the table here. After you get this one, you will plot the point on a graph paper to find the graph of the exponential function. That means when x is equal to negative 2 here, and then the corresponding y value is equal to negative 0.25. You find that it is the first point, second point, third point, fourth, and the fifth point. And then the 6, 7, 8, and 9 point also plotting. After you plot the 9 points, you can use a hand feed to connect them. You will have the shape just like this graph. It's just like a line. We must have some properties about this line. If you are putting x equal to 0, you will get the y equal to 1. So it passes through the point 0, 1. It is very, very important. It is not depend on the base. If you have another base like 3, you still, when putting x equal to 0, y is equal to 1. And we define that the function is with a base a. A cannot be equal to 1 and must be greater than 0. So we will try to discuss them later with the base. But now I also want to discuss when the x is greater than 0. That means we consider the part with x greater than 0, which is this part. You find that all the y value, that is the height of the point, always great higher than the 1. So we have the conclusion: when x is greater than 0, y is greater than 1. Y is greater than 1. But when x is less than 0, that means we consider the left hand side. When x is less than 0, you see the green points here all lies under the y value with 1. So that means when x is less than 0, y will be less than 1. But you cannot find that this one will be go down to pass through the x-axis. So that means it will also greater than 0. How about the shape of the graph? We say that this point go to this point, you are saying increase. If this point go to this point, you are saying increase, because when you're moving to the right hand side, the y value will be going up, so it is increasing. But in the increasing, we also want to find the rate. What's the meaning of rate? In here, go to here, you use 2 steps to rise up, 1 and 2. But if in another way you have 2 steps to rise, is more. So the rate here increasing is more larger than this one. So we describe this one: when the value of x increase, the value of y increase. X increase, y increase. And also the rate of increase of y is also increased. The rate of increase of y, the rate of here is like this, and from the 0 to 2 you increase like this. So the rate is increased also. So we always say that the graph rolls upward from to the left to right, and when x is increased, y is increased, and so the rate of increase of y. So you must using this description to describe the graph of your function of exponential. Now let's do some class activity. When you drawing some graph, we also have a reference graph, just like this one. The reference graph is like this. You are given the graph of y equal to 2 to the power x, but you want to draw a graph y equal to 4 to the power x. So in order to draw them, you must also find the corresponding values of the point. So we put here, and then we get, using your calculator, find out the values of them. Then we can plot the graph. So when x equal to negative 2, you will get a value is 0.0625, which is less than the previous one, 2 to the power x. Go to here, it is also less than the previous one, and then up to the 0. When x is 0, the y is equal to 1. At that point, it is the same as the previous one. So when we connect all the points, I can find out the graph like this. So you see that there's a point. We always say that this is the same point. No matter what is your base, when you're putting x equal to 0, 2 to the power 0 or 4 to the power 0, your y is still 1. So according to the graph, y equal to 4 to the power x, the answer of the following question is, does the graph cut the y-axis? Sure. And also, what is the value you will cut at? The value is the point is called 0, 1. Okay. Does the graph cut the x-axis? Similarly, for the graph, this one will be going down, but this one does not pass through the x-axis, so it will not cut the x-axis. And does the graph above the x-axis? You see that the green color and also the red color line both are over the x-axis. That means they lies over above the x-axis. And also that means the all values of y is greater than 0. Also, we want to find whether the trace of your graph. In the previous one, we say that it is increasing, and we say the slope are upward from left to right. And also this one appear for the exponential graph for the part D. So we say when the value of x increase, the values of y increase, and the rate of increase of y increase also. So you must notify that we always using this to describe the this sentence to describe the graph. Finally, we say that do the graph have the same common property? Sure, they have the same property if you compare the previous page. Now we just consider a number which is 2 and 4. Both of them are positive, greater than 1. But if a number which is less than 1, what will be? We will see the next page. When we consider y equal to 1 over 2 to the power x, we plot the graph. If you compare this table with the y equal to 2 to the power x, they are flipping around. That means they are it is symmetric. That means the value of x is 0.5. In y equal to 2, you get 1.4. And when x equal to 1 in y equal to 2 to the power x, you get 2. So the values here will be interchange. So if you want to plot the graph of this one, you just like using a mirror here, just like the y-axis, and reflect this about the mirror, you will get the graph of this one. Because 2 and 1 over 2, they multiply together, is just equal to 1. So this one, 2, and 1 over 2, we have say that they multiply become a unity. That means they multiply equal to 1. If they have these properties, then the graph will be reflected about by the y-axis. So we have the properties. This one also passes through the point called 0, 1. So no matter what is the base, greater than 1 or between 0 and 1, still passing through the point 0, 1. And the graph is also above the x-axis, because when you reflect this graph, you still have the graph over the x-axis. But they have another way. In when the base is greater than 1, you find that after when x greater than 0, it will be y greater than 1. But because it is 1 over 2 is just the refraction of that means they have the other. When x greater than 0, the y is just less than 1 and greater than 0. On the other way, when x is less than 0, the values of y will be greater than 1. So it's just the refraction of the graph. But the description for this one, that is when the base A is just less than 1, greater than 0, what is it? The graph slope downward from left to right. Because you see that this one will be decrease here. And then the rate is from the here, and then here, and then here. So the rate is also decreasing. So we say that when the value of x increase, the value of y decrease, and so does the rate of y. In general, when the base A with the values between 0 and 1, you have the properties like this. So compare them, we have a summarized table. If A is greater than 1 and A is between 0 and 1, you both have the common properties pass through the point 0, 1. They are all over the x-axis. Okay? And then and the image of 1 over a to the power x, the graph is the image of the other one by reflecting the y-axis. So that means you're flipping the graph by using y as a center. But if you have a greater than 0, this one will be going like this one. If you have a value of base A which is between 0 and 1, you have the graph like this. So we'll have some properties about this to describe. Here the graph of each of the following exponents cut the y-axis at the point P. Find the coordinate of P. According to the properties, the common property for these two graphs, they both pass through C1. So when you're looking at the graph, you always locate the 2 points are both equal to 0, 1. Question 2, you are given the 3 curves to represent the 3 exponential function, but with 2 a and b are known. But by looking at the graph, you can see whether a and b are related to the number 5. The first one is to determine the a, whether it is greater than, equal, or less than 5. If the graph of y equal to b over x and are symmetric about the y-axis, find the values of y. Here, what's the meaning of symmetric about the y-axis? Means that y as the mirror. This graph is refracted to here. So we can observe the graph like this. We can draw a rectangle which is passing through the 1 and -1 of your x-axis. So when x, and also another graph, the rectangle which is passing through the line of the y equal to a to the power x. According to this one, this value is, what is the value of this one? You can see when you're putting x equal to 1 in this graph, and then it is a to the power 1. So this value is the a. So we can say this is a. And for the green line, when you putting x equal to 1, and you will get it is 5 to the power 1, so that means this is 5. So 5 is higher than a, so we can say a is less than 5. Another way, this one is symmetric, so when you putting x equal to 1, you will get the values of y. It's just the same putting x equal to -1 in this graph. So this one is b to the power -1. That means b to the power -1 is equal to 5. According to the formula, b is just equal to 1 over 5. So go back to your function, you will get this one. Part A, it is less than 5. For A is less than 5. For part B, B is just 1 over 5. One more example about graph. The figure shows the graph of the exponential function of y equal to a to the power x and y equal to b to the power x, and a and b are constant. You can see that here you will find two graphs. The graph here is y equal to a to the power x, so this one is going upward, so I can sure that a must be greater than 1. And b is going exponential graph, which is going down, so we must sure that b is less than 1 and greater than 0. The first one we observe from the graph is like this, just like this diagram. If you want to change the values, you will get the graph like this, and so on. We can check this one by putting A and B and C also. Now let's look at the following. The first one, we say A is greater than 1, so and also the graph of y equal to b to a is the symmetric about the y-axis, so that means b is just the reciprocal of a, so b is 1 over a. And the second information provided by the questions is the sum of a and b is greater than 5. So we add these two values together is greater than 5. And then using the graph, we may put the a equal to a certain values by looking at this. When you putting here from the first one, here when a is equal to 1, a is equal to 2, then b is equal to 1 over 2, but they add up is just 5 over 2. So you add one more when a is equal to 3 and b is become 1 over 3. They add up is 10 over 3, which is less than 5, so not correct. The next one, when a is equal to 4, you will find that b is equal to 1 over 4, and the value calculate of the sum of AB is 17 over 4, which is also less than 5. So up to here, we do not satisfy the condition. So the next step, when x is 5 and the b is 1 over 5, they add up must be greater than 5. The next 6 also okay, and 7 6 is also okay, and 7 also okay. So we just take a pair of them that satisfy, so you can take 7. In this question, you can also write down the other pair, which is 6 and 1 over 6. So in these questions, you will have the things like this. 1.5 to the power x you are given. If you draw two rectangles, just I do it before, we can find that a must be greater than 1.5. And because y equal to b to the power x is the reflected about the y-axis by the graph of y equal to x, you have another graph. So we first make a number a which is greater than 1.5, so a can be 2. If you take a is equal to 2, then b is just the reciprocal of a, so b is equal to 1/2. So it is a possible case. You can also take maybe a equal to 3, then you will get b is equal to 1/3. Because this is called an open-ended question, so you will have many answer. You just give one pair is enough. The last part of chapter 7 is about the application of the exponential function. This function always find in daily life. The change of the quantity will describe like an exponential function. You learned about the compound interest. That is, you learned in Form 3. That means, or maybe called a successive increase of certain objects. That is, here the original number of bacteria in a tart sausage is 1,000. The bacteria reproduce in the sausage, the number increased by 1% for every minute. Let the number of bacteria in the tart after x minutes be n. So according to the successive increase, we can repeat this 1 plus 1% x time. So we will have the formula like this. And this one, you have a constant a here, constant a, 1,000. And then this is a base, here is 1.01, and then power x. That means it is not exactly the exponential function. It will be a part of exponential function multiplied with a constant here. So there's an example. You will always giving the formula for the exponential function. Like this, the population of a town is 37,000 in 2014. That means in this year, the starting population is 37,000. The population of the town after t years. This means that the t is counted from 2014. If you want to calculate 2015, the t become 1. 2016, then t become 2. And then you can represent the formula by the following. P is equal to A just like the number 1,000 in the previous part, and that the base 1.015 is the base. Just look at this one, 1.01, and T is represented by the time, so it in year, which is similar to the X. So in different question, you will have different symbol to represent the constant here and the power here. So be careful. So T is the time when you want to put here, you can calculate something. According to these questions, that means when T is equal to 0, because T is measured from 2004, so when T is 0, the population will be 37,000. So in part A, if you want to find the A, you must putting the values of T equal to 0 and P equal to 37,000. So the A to the power 0 is a very important thing in a daily life problem. Now when we putting T equal to 0, P equal to 37,000, we get the A is 37,000. After you get this 37,000, you put back to the original position of the A, and then you want to find what is the population in 2018. Now 2018, you just calculate the years between them. So you're using 2018 minus 2004, you get 4. And putting with the value of A equal to 37,000 and T equal to 4, you calculate it is 39,000. That means in 4 years, the population increased approximately 2,000 people. So in this kind of problem, the first you must put the T equal to something and P equal to something to find the constant here. Let's look at this. The original bacteria of a bottle culture solution is 100. The number of bacteria after n hours can be represented by here. Here is another exponential function with a constant k and the index n. And you know that n is represent after n hour. So when n equal to 0, it is the initial number of bacteria. That means the p is equal to 100. So when you putting 100 here, 100 here, and n equal to 0, you can calculate k is equal to 100. After you put the k equal to 100 back to here, times 1.2 to the power n. Because n now is putting 3, so you will get the value of p is equal to 100 times 1.2 to the power 3, and you will get the answer here. It is 173. Another example will be like this. You are not given the initial condition, but you are given you are given the constant k here, but you are not giving the constant base and the power. So you will have in a district the number of n distillery accident in the M1 after a Stricker law is adopted like this. It is known that the number of industry accident in the district in the third month, that means m equal to 3. After the restrict law is adopted to be 27. That means this one, when putting m equal to 3, the n is equal to 27. So we're putting the value here. I get k to the power 3 is equal to 0.216. By the first section of this chapter, we know that k is the cube root of the 0.216, so we can get 0.6. Now the base here is this number which is less than 1 and greater than 0. So the graph will decrease like this. So when you will want to get the values here, you always find that when k is 0.6 and then 0.6 to the power m, any m greater than 0, that means here is always less than 1. So we say that 0.6 to the power m is always less than 1. After you have this one, that means the formula 125 times 0.6 to the power m is always less than 125 times 1, which less than 125. So this is a conclusion that the number of accidents will not be exceeds 125. Let's look at the example. A new computer virus spreads on internet. The number n infected computers after T hours can be estimated by the following formula. You are given the formula, and you are also given an information. That is after 2 hours, the number of bacteria is 507. And you want to find the values of k. That means when you're putting n equal to 507, t is equal to 2. And the most difficult part is the part B. You want to check is it the number of virus is less than 300 or not. So we must first find out the formula and then check the values. By putting n equal to 507 and t equal to 2, we have a 507 equal to 300 k square. Then k square is equal to 500 over 7 and over 300, which is 1.69. By taking square root, we just pick the positive one because the base must be positive, so it's 1.3. Now we have the k is equal to 1.3, but after you know that this k must be a number greater than 1, so we first write down it is 1. If this is less than 1, you may write down k is less than 1 and greater than 0. Now k is greater than 1 when you power anything with a positive, which is the power t here. You have the t here. So it is still greater than 1. And then you may also multiply the value of 300 on both sides by the inequality. We get 300k to the power t is greater than 300. That means this is the number of bacteria, and the number of bacteria is greater than 300. That means the question here, you want to say whether the inventory number is less than, so it is no. The number of is not less than 300. Let's look at another example. Here you are giving the m0 gram of a radioactive substance Y. That means at time t, the equal to 0, the number of the mass of the element is m0. Will be reduced to m gram. X day will be with this formula. So this m0 is the called initial value, which is given directly from here. Or you can just calculate it by putting m equal to 100 and x equal to 0. So you get m0 equal to 100. But in this case, you can just skip it and just write down m0 is 100. And you are given another information. It is after 5 days. That means the x is 5. Then the number of the mass of the element is equal to 86.8. So you put the value 68.8 equal to 100 times a to the power 5. Now you will get a to the power 5 is just 0.865. And then by the definition of the n root, we have a is the fifth root of the 0.868. You must keep this expression because you may have a further calculation, but in this part you want to give the answer to 3 significance, so you press your calculator, you get 0.972. You can use this value direct for the next part, but if you take it, it is an error. If you want to reduce the error, you try to use this expression. So in the part B, John claims that the mass will be more than 25%, reduce more than 25%. So you want to find the percentage decrease. Is this more than 25? So we must know what is the mass of the element of Y after 10 days. So we put x equal to 10 in the formula. It is 100 times A. A is the value you taking here. So you get this one. Why we take this one? Because this is the exact value. You do not have any error when you're using this value. So here you have this is 1/5 the power, and then you have power 10, then you cancel, will become power 2 here. So the answer is very easy, just time 100 with the 0.863 to the power 2. Then this value you need not to calculate at that moment. You just want to find the percentage decrease. By the formula, the old value minus the the percentage is the old value minus the new value divided by the old value times 100%. You calculate 24.7%, and which is less than 25%. But John claimed it is more than, so the claim is disagreed. Now let's look at the last example of this chapter. The value of a car is 100,000 now. That means when t equal to 0, the number the value of it is 100,000. So this one is just like the m log of the previous example. And the value of v will be follow the formula like this. It is 100,000 times b to the power t. It is known that the value of car will be 40,000 after 4 years. You want to find the value of b. So you direct right, putting t equal to 4 and v equal to 40,000 in part A, and we get the formula 40,000 is equal to 100,000 b to the power 4. And then b to the power 4 become equal to 0.4. So you take the fourth root of the 0.4, we get 0.795. You can using this value for the further calculation, but you don't. If you don't, you may try to use this exact value. Now when the second part, it is another person's chosen, claims that the car value will decrease more than 25%. So you must first calculate what is the values of the car after 6 years. So you put t equal to 6, and then you have the formula 100,000 times the fourth root of 0.4 to the power 6. But this 0.4 fourth root of 0 is just 0.4 to the power 1 over 4. So by indexing, you will get it is 0.4 to the power 3 over 2. And you need not to calculate this value, you just want to calculate the percentage change. So using the old value minus new value divided by old value times 100%, you get is 24.7%, and which is less than 75%. So the claims here is also disagree. This is the example, so you can try the problem in the exercise.